Can we get the slides up on the screen? Don't you like these flowers actually over here? They fit very nicely in that little forest which we have on the stage. So I will talk a little bit about flowers. Now, before I do that, who has seen the cherry blossoms in life? Who has been in Japan lately, in China, or in Europe and seen these kind of fantastic flowers blossoming everywhere there? Hands up, actually, who has seen that? Quite a number of people, actually. Fantastic. What impressed you most about seeing the cherry blossom over there? Any kind of feedback? What did you like about it? They're everywhere, exactly. They're everywhere. They're blossoming all over the place. They have a fantastic color. They look very alive, actually. Everything is happening at the same time. We have hundreds of different trees in some areas in Tokyo and Osaka, for example. And the inspiration for this picture and the presentation here today came to me while I was on a train going back from Osaka to Tokyo a couple of weeks ago, where I visited a large customer of ours. And they're at the moment rolling out large IoT applications in Japan. And I thought it's a good time to maybe talk a little bit about where do we see now IoT really happening. We have been talking about it for a long time. Last year I spoke here about applications which we are developing. We are now seeing that this is really happening on a wide scale. And as Bosch, we are exposed to quite a number of different sectors actually. So what I would like to do today, to tell you a little bit more about where do we see these inflection points right now? Where is actually IoT really happening on a large scale? And obviously we are also exposed to quite a number of aspects of that. We are doing everything from the hardware, the sensors, to the software and the services actually, right? We're involved in the whole ecosystem. And that gives us a good overview of what is happening around the industry. And if you look at the results over the last year alone, since last year, right? We have been putting out more than 60% of our things, and we are producing about 1 million things a day, right? Whether it's appliances, whether it's stuff goes into cars, whether it's power tools, anything like that. More than 60% of our, what we call product classes, are now IP enabled and are having an API which software developers can take and which they can develop on top of that, new services, new business models and so on. And that's really, really exciting. We are planning by 2020 to be at 80% and we are well on track actually in that regard. We have by now more than 170 solutions actually deployed, and I will come back to that specific point to tell you in which areas this is. But this is something which we have done over the last 10 years now, and so there's a very good kind of track record to now reflect back on what is really happening there, what is reality and what is hype. And as I said, alone last year, 38 million IP-enabled products sold, whether these are dongles going into cars, like here in Singapore, for example. Lately, one of the insurance companies here in Singapore launched a little dongle together with the insurance, which is detecting whether there's potentially an accident. If there's an accident, it warns the emergency services, much better safety, much better care on the road, lesser accidents, hopefully, or lesser casualties as a result. Now, we have been starting 10 years ago to do this. In 2008, specifically, Bosch Software Innovations, as the incubation, acceleration, technology development arm for IoT for Bosch was started. And we have now done a lot of stuff all around the world. We have about 600 people now doing nothing else than that within even our own area. We have a couple of thousand people now within Bosch doing it on a much larger scale. And as I said, I will tell you a little bit more where that is now resulting in real business being generated. Now, the way how we do this, just to tell you a little bit more, is on one side, obviously, we are a technology provider. You see on the right side certain tools, certain platforms we are offering. We are then working into sectors where we as Bosch have some domain experience, right? You will not see healthcare, for example, on here. That's not really our domain. But we are strong in everything from automotive, mobility, to manufacturing, and something which I find very exciting these days, and that is also where the flowers again come in, and very nicely this forest here on stage is agriculture, and I will come back to that point in a moment also, okay? But just to tell you a little bit more about how we are doing things, how we are doing the Internet of Things, so to say, as we developed our own set of tools, so to say, for this. This is available as a cloud-based platform. And these are the kind of service, everything from picking up the data from the devices, aggregating it actually, doing the device management. Obviously, when we now have millions of devices in the field, you cannot run after all of them and do that actually manually. You need to have automatic processes. And we then do the digital twins in the cloud. We do the analytics and all these kind of things. And you see this is available on a number of different clouds. I will also show you in a moment where that is available and how you can access that. One thing very exciting right now, the Eclipse organization. Who knows Eclipse? A lot of people should, right? Yeah. As soon as we're in the software sector, we know Eclipse as one of the open source platforms in the world. We are working very closely with them. They recently did a survey, and on top of that, on the left side, you see the key concerns by software developers developing applications for the IoT. And 3 of them, they were present already last year or 2 years ago when they did that first. It's still security, it's still the hardware side, and it's obviously also connectivity still. But there's one key concern now arising, and that is the result of IoT now going broad. Because we now have so many devices out there in the field that the acquisition and the persistence of all that data is becoming a key concern. And that is something which we have been doing since quite a while. I will tell you in a moment about the number of cars on the road which are connected already. And so we have had the requirements since quite a while to do this on a very large scale. We are now actually going to provide this as a cloud service over the next couple of months. So watch that space. You're going to see a service called IoT Insights going to appear, and that allows you exactly to do that very, very easily and very conveniently. Now, before I go to the use cases and examples there, one more thing I want to tell, especially the software developers in this room. Most of the code base which we have developed as part of this toolbox of services is actually available open source. That is, these are the project names actually. It's all available under Eclipse actually, iot.org. And so you can use that source code freely. You can work with it to develop your own POCs, to develop your own kind of projects. If you want to then have it run as a service and don't have to worry about all of that, then we can of course do that for you. But let's come to the use cases. By the way, this is the link where you can access all the services. There are free services available. Just start to play around with it. I'll tell you later on also about the hardware side, where you can also complement that very easily with the respective sensors. But let me come to the use cases. I told you just now I will tell you about the number of cars which are currently connected on the road. We have currently 3 million cars at any given point in time which we are monitoring on the road live. So that is seriously big data, what is currently happening there. That is being used to look at the components in the car, to look at brake systems, for example, to look at the performance of any kind of components in there. That's one aspect. Being able to improve on how things are being done. For example, a brake, you want to have a brake working properly actually. On the other side, it's being used to understand better the user behavior in cars and how people want to actually interact with their cars and with services actually in and outside of the car. And obviously all of that is a precursor to what? Autonomous vehicles, of course, right? Ultimately, autonomous vehicles will be permanently connected devices. There's just no choice about that. But just think about it already today. A modern car has about 1 to 2 million lines of code in there. Updating that kind of software requires specific processes. For example, firmware updates over the air, something which you have seen from Tesla and others before. Nowadays, for example, there every month from one of the key OEMs, 200,000 connected cars falling off the production line using these kind of processes, using these toolboxes actually there, right? We are expecting in 2025 that there are 470 million connected cars on the road. So just imagine that kind of opportunity actually, having that link into these kind of devices, being able to offer new services actually on top of that. All of that is going to happen over the next couple of years. Another area which we are really excited about, that is the number 2 kind of use case we see across the industries we are active in, is manufacturing. Industry 4.0, connected manufacturing, factory of the future, however you want to call it, is happening right now. We are seeing that shop floors are comprehensively getting connected, even retrofitted, right, with older machines, retrofitted with sensors, being provided with capabilities to provide us more insights, and therewith being able to take all of that data together and to optimize ultimately the OEE, the efficiency in the plant. That's one of the KPIs in the plant, to make sure that ultimately we are doing the manufacturing job as best as possible. We are running 270 manufacturing plants around the world. We are using it ourselves. We are doing it for a lot of clients, whether it's in Europe like Osram, whether it's in China, aerospace manufacturing, it's telecommunications manufacturing and so on. It applies more or less everywhere. You also see it in the process industry happening very, very widely actually right now. So that's the number 2 most significant opportunity which we see. I tell you about a few more of them which are still emerging. One of them is smart homes. You will see later on this year in Singapore a fairly significant pilot which is going to be launched for houses here in Singapore to be fully connected, to have smart home systems built into them actually for energy efficiency purposes. I just mentioned before I was on the way from Osaka. There's going to be a launch in the next couple of days in Japan, in one part of Japan, where they're going to launch 300,000 smart homes actually. Also you're looking specifically at energy efficiency, but also looking at what we saw in the last panel before, connecting a lot of different domains within the home together and starting to pull this together as homogeneous services actually residing on top of that. So that's another very exciting opportunity which we are still seeing emerging actually. That's not yet so big, but I think that is something, if you're interested in that sector, that's going to be a very, very interesting opportunity over the next couple of years. Another one, as a result of that, somewhat connected, are connected buildings. We had buildings for a long time where we looked at HVAC units actually, where we looked at the lighting systems and stuff like that. There's a lot more which can be done nowadays, and more importantly, not something which you need to do like in the past when the building was built. The fascinating part about IoT is also you can retrofit a lot of these kind of things now, right? The sensors are relatively affordable these days. They're wirelessly connected. We have the capabilities on the back-end side to readily take in that information. We have the ability to connect easily into legacy systems like building management systems, for example. And that gives us an agility layer which we can put on top of all of that, providing us additional insights about, for example, air quality, the space management, all these kind of things which might not have been possible a while ago actually, and do that relatively affordable actually, right? And that's a big change. It also allows us to ultimately then connect a lot of systems together as a system of systems kind of approach, which was also before very hard to do because we had these very monolithic systems actually there, which were all separate ultimately, okay? So that's another very big thing. As a result of that, of course, you can extrapolate that into smart cities. That's a wholly different discussion, but also a very exciting kind of opportunity too, okay? Now something I mentioned right at the beginning, flowers, agriculture and so on. This is something I'm personally most excited about to some extent, because that's a new area which we haven't really looked at too much over the last decades. Agriculture has been on a certain level in terms of automation and so on. Yes, we have been driving that forward, but now we have a paradigm shift. Now with the use of artificial intelligence, with the use of relatively inexpensive sensors, we can actually look more specifically what is happening in the fields, what is happening in the greenhouses, what is happening in vertical farms, for example, what is happening in the water ponds actually where shrimps are being grown. We can look specifically at the conditions within that and determine what is going on, and then use that data to actually think about how we can do stuff better. So this is an example. It's called PlantTech. We launched that last year in Japan. It's connected tomatoes, right? Connected tomatoes, tomatoes because they are being grown in greenhouses. In greenhouses, there are certain conditions, and under certain kind of conditions, certain diseases are going to spread in greenhouse, and it's very hard to contain them. You need to use a lot of chemicals and stuff like that. Now, the good thing is about that, you can actually determine very well beforehand when the conditions are ripe that certain diseases are going to spread in there, like mildew, for example, etc., right? And so we have developed a set of hardware. You see the hardware there, which contains a number of different sensors, actually temperature, humidity, CO2, light, and so on. And combining these actually, looking at it through the glasses of machine learning, we are able to predict with a 90% probability when certain conditions exist which will allow the spread of diseases before they have even started. And you can then adjust the factors in the greenhouse to make sure it doesn't happen. Or you can then, when it's already a little bit further maybe, you can decide where you use chemicals, but you can use a lot less potentially, right? That's not necessarily something the chemical companies are going to love, but they're also getting in on it because they realize that this is what is going to happen in the future, right? It's the more efficient application of the input factors, so to say, whether it's food in shrimp farming, whether it's chemicals in these kind of greenhouse environments, or whether it's large broccoli farms, for example. I was recently in Australia looking at broccoli fields. And it's amazing, actually, when you have a 1 hectare broccoli field, how many microclimates there are in this one field. It's really astonishing. 4 or 5 different microclimates across a 1 hectare field, actually. So with the use of sensors, we can determine these. We can make sure that irrigation and everything else is adapted to that specific microclimate in that area and can, as a result, increase the yield. That is one of the companies in Australia we're working closely with. Google it under the yield. They are doing some fantastic and very exciting stuff there. Okay? Good. So that's about agriculture a little bit. There would be a lot more to talk about, but I think we don't have so much time today. Obviously, we are very happy to help you and everybody else who is interested to work through that process. It is not easy still. It is something where you need to think closely about, starting on the left side, especially the business models. So for example, that Plantech solution, that's a monthly subscription. Nobody's going to buy the hardware, needs to buy the hardware, anything like that. It's very easy. You just hang it in there and the whole thing starts to work, actually, right? Very straightforward, very easy, and in terms of the business model, quite different to what farmers were used to in the past. So that's something which we need to think about, and obviously then the whole thing from a POC to an MVP and so on. That's something which we certainly do. If you want to experiment with that, there is a piece of hardware also available, this little kit there, for example. You can Google it, you can buy it online, on Amazon, etc. It's directly connected into the cloud, and you can, with that, it has 8 different sensory capabilities available. It's hardened to use in POCs and stuff like that. You can very easily start retrofitting a machine, retrofitting a certain kind of device. It has, for example, similar sensors to what we have in the agriculture solution also in there, a part of the CO2, and can start very easily and quickly doing your own experiments, doing your own POCs before you then want to scale that up. And the beautiful part now is it's really blossoming, it's becoming easy, it's going everywhere. The panel before said the biggest opportunity for digital transformation is also now to see how this is breaking down the silos, and that's exactly what we are seeing here also, that kind of opportunity. Automotive starting to relate to appliances at home and everything else around it. With that, thank you very much, and I'm very happy to answer any questions you might have.